All right. Good morning, everybody, especially Victor, Jen Rancis, Billy, Justin, Chriselle, Kiefer, and John Raphael. So, we are at week number 14 of the SEM, and konti na lang, konting push na lang. We are on the finish line, at least for the end of classes. Pero meron pa tayong final exam, ano? Meron pa kayong final exam. But the pre-final exam, hopefully you already made arrangements for it, would be on Monday, December 12th, from 10 to 12 noon sa MB 101. All right. So again, the pre-final exam, make sure you're there because aside from valid excused or excuse evidenced by valid excuse slip from the college secretary, there would be no replacement for the pre-final exam. Baka later kung excuse yung absence ay face-to-face final exam, yung magiging kapalit niya. So be there. Kung hindi excuse, pasensyahan tayo. I-zero ko talaga kayo sa pre-final exam. That's 30% of your final grade, so make sure you're there. Again, that's on Monday, December 12th, 10 to 12 noon, and it's at MB 101. If you're not free during that time because of some other commitments, you should tell me within the week so that I can schedule an alternative time for you during the same day. All right? So kausapin niyo ako kagad because otherwise, hindi ko kayo mahanapan ng oras. Unti-unti nang na-fully book yung araw ko on Monday. Specifically, I think on Monday, I'll be, sabihan nyo na lang ako. Kasi 8:30 to 10, baka nasa rural high school ako. And then magpapa-exam ako ng 10 to 12. And then sa hapon, meron kaming online APC meeting. But I can proctor the exam. Kailangan ko lang magsalita pa minsan-minsan in the APC meeting. So yeah, sabihan nyo ako kagad kasi napupuno na yung sched ko. Ano? So, and then what else? Yeah, I think that's it. And and then as for the final project, as I've mentioned, I'll be rolling out some of the problems for the problem set. For the final project. Tapos ako na yung mag-group sa inyo. So i-announce ko na lang yung grouping probably within the week or early next week para makapagsimula na kayong gumawa. It is worth 20% of your final grade. I'll give you a certain problem, a certain application problem that you will explore with your peers. Tapos, the deadline would be January 11. More on this siguro next week na lang kasi kailangan ko magmadali today at tapusin as much as possible because the coverage of the pre-final exam would be until whatever will finish on Friday. Okay? Pero mangyayari because I don't expect to finish everything by Friday, so meron pa ring part ng Math 151 na hindi ko may sasama sa exam na face-to-face but I'll make it as a part 2 of the pre-final exam. Right? And the deadline for that would be probably the last day of classes. Let's negotiate about that next week, depende dun sa coverage. Pero ang paggandaan nyo yung face-to-face exam sa Monday, ng coverage ay hanggang kung saan man yung matatapos natin hanggang sa Friday. Then let's talk about the take-home component next week. Ano? So I hope that's clear. And then part of the final project is, or part of the grade in the final project would be your evaluations of me and the course. Ang pinaka-urgent at pinaka-crucial ay yung student evaluation of teachers that is ongoing in SAIS. So sagutan nyo na siya, specifically para sa 151, pero in general, lahat ng teachers nyo i-evaluate nyo doon. Yun yung panahon nyo para makabawi sa amin or give us an appreciation grade if you think we did well. If you think we didn't do well, then let us know and give us a grade from there. And doon talaga namin makikita yung performance nyo. Doon namin makikita yung tingin nyo doon sa naging performance namin. Alright? So hold on guys, let me, so nag-post na ako ng homework, ng quiz kay Canvas. So look at the quiz, it is declared under the final project. So sagutan nyo lang yun ng yes or no. Pag nakapagsagot na kayo kay SAIS, click yes, you'll get the 5 points out of 100 dun sa final project. And then another evaluation will be rolled out probably next week. Yun naman yung another 5 points. So a total of 10 points out of 100 will be of the final project will be allotted for your evaluation. So kailangan nyo siyang seryosohin at kailangan niyo siyang sagutan. Alright? So give me 1 minute, guys. Hold on. All right, so I'm back. So let's see, what did we do last time? Well, we started talking about the Laplace transform. Yeah. And we said that the Laplace transform of a given function capital F would be is defined this way. So we take the Laplace operator. I usually write it as curly L, pero ang ginamit dun sa PowerPoint slides ay capital L. Hindi ko ma-edit yung equations kasi magkaiba kami ng equation editor na gamit. But so whenever I'm writing things, I'll use curly L for the Laplace transform. The slides will use capital L, but they're the same thing, So if you have a function capital F of the variable t, right? So isa siyang function ng t. Ito-transform natin siya by into a function in the frequency domain. So pwede nyo tingnan to as a time domain function. Ililipat ko siya ng domain. Ililipat ko siya ng kabilang dimension. Ililipat ko siya sa dimension ni Laplace. Pag meron kang isang function capital F of the variable t, pag transform mo to in the Laplace domain, kukunin mo yung integral from, hold on, let me see exactly how we defined it. Kasi yung iba, integral from negative infinity to infinity, but I guess our Laplace transform ay 0 to negative st. 0 to infinity. Okay, good. Kasi iba-iba rin sila ng convention. So this is 0 to infinity of e to the negative st f of t dt. Right? So you evaluate this improper integral, and if it exists, this is called the Laplace transform of our function. We denote it by little f of s. Or pwede rin natin siyang tawagin na f tilde of s. Right? So yan yung mga alternative notations natin para sa Laplace transform. I guess the most noticeable is this guy, pero mahaba siya, no? Laplace transform ni capital F and evaluate as this integral, makukuha natin yung Laplace transform niya. Yung itsura niya dun sa Laplace domain. It will be a function f of s, or whenever if naubusan na kayo ng variable, instead na umisip pa kayo ng ibang variable para dun sa Laplace transform, lagyan nyo na lang ng tilde sa ibabaw si f para ngayon, alam ko na, ngayong capital F tilde, ito yung itsura ni capital F but in the Laplace domain. Okay? Now, this will become helpful in solving ordinary differential equations. So kasi as I mentioned earlier, kapag ka meron kang ODE, pwede mong kunin yung Laplace transform ng both sides ng ODE na yon, right? Makukuha mo yung equation in the Laplace domain. And the nice thing about the equation in the Laplace domain is that it is free of the derivatives. So if you have an equation in the time domain or in the usual domain that involves the derivatives of a function, when you go to the Laplace domain, makukuha mong makukuha mong equation ay wala ng derivatives. It will just be an algebraic equation. An equation related via plus or minuses, via the basic arithmetical operations involving some elementary functions. Tapos ang magiging challenge para sa atin ay paano i-solve yung algebraic equation na yon. Tapos pag nakuha na natin yung solution in the Laplace domain, kukunin ko yung inverse Laplace transform niya para ma-convert ko siya pabalik in the time domain. So parang humanap tayo ng lusot, right? So kung mahirap i-solve sa totoong buhay yung isang problema, lilipat tayo ng kabilang dimension sa Laplace domain kasi wala daw mga derivatives. Tapos, pag nasa Laplace domain na ako, nakuha ko yung solution, saka ko i-convert pabalik doon sa totoong universe o doon sa totoong domain. Right? Of course, we don't want to evaluate this improper integral whenever we need the Laplace transform. So basically, I encourage you to make a list of Laplace transforms. Tapos, sauluhin siya, at least para sa exam, kasi close notes yung exam. So, ito yung mga common Laplace transforms na meron tayo. So, we have the Laplace transform of an exponential function, e to the kt, right? So, k is a constant, t is your variable. Its Laplace transform is 1 over s minus k. And this is the value when s is greater than k. In general, you can choose s to be as large as possible, or S should be sufficiently large so that the Laplace transform will exist. Because the Laplace transform won't always exist. Nakita natin nung ginamit natin yung definition to compute for the Laplace transform of e to the kt, there are some values of k for which the Laplace transform will not exist because the improper integral will not exist. But we are sure that that improper integral will exist if S is greater than k. So ang Laplace transform ng exponential ay nagiging rational, 1 over s minus k. And this is a clue for you kasi sabi ko kanina, yung derivative equation or yung differential equation, ito translate ko into an algebraic equation involving Laplace transforms. Yung mga Laplace transforms, mukhang mga rational functions yung mga yan. So ibig sabihin, dapat ngayon pa lang alalahanin nyo na yung mga methods kung paano mag-solve ng rational equations. Specifically, the method of what? Partial fraction decomposition. So gamit na gamit natin sila kasi sa Laplace transforms, usually the action happens at the denominator. Okay? Now, another Laplace transforms would be for sines and cosines. Sorry. The Laplace transform of sine kt ay equal lamang sa k over s squared plus k squared. The condition here is that s must be positive. Laplace transform of cosine kt is s over s squared plus k squared with the same condition. Magkamukha sila, kaya lang kapag nag-start na kay letter S yung trigonometric, yung Laplace hindi dapat mag-start sa letter S. Yun yung palatandaan ko dito sa dalawa. Yung cosine, dahil nag-start siya sa letter C, pwede siya mag-start sa variable S din sa right-hand side. So yun yung mga mnemonic devices ko dyan. Kasi I have the memory of a goldfish, so maiksi lang talaga yung memory span ko. Lalo na kung hindi ko siya madalas ginagamit. And then we have the Laplace transform of t to the power n. So isang power function. This is equal to n factorial over s to the n plus 1. The restriction s is positive. And then in the exercises, you were told to verify that the Laplace transform of the hyperbolic cosine of kt ay equal sa, dahil nag-start sa letter C yung hyperbolic, so pwede mag-start sa S yung Laplace transform. S squared minus k squared, but in this case, you want S to be greater than the absolute value of k. And then the Laplace transform of the hyperbolic sine of kt I equals k over s squared minus k squared. S must be greater than the absolute value of k. Right? And then aside from these, sa mga applications, ito pa yung mga lumalabas na Laplace transforms. Probably in the project, you will meet them. Ano? So kaya ibibigay ko na rin yung Laplace transforms nila. Ang Laplace transform ng e to the negative alpha t. Hold on. Okay. Laplace transform of e to the negative alpha t times sine beta t, or sine beta t. Ito ay equal kay beta over s squared plus alpha squared. Sorry, hold on. Beta over, ito na yung memory of a goldfish. Beta over s plus alpha quantity squared plus beta squared. Yun. And the restriction here is S should be greater than negative alpha. Nangyayari to para sa mga harmonic motion na nagde-decay exponentially. So meron kang harmonic motion or oscillatory motion na ini-scale by a decreasing exponential function. So parang ano siya, vibrations in a string. So usually exponential times trigonometric yung solutions niya. And similarly, the Laplace transform of an exponentially decaying cosine wave ay equal kay S plus alpha over S plus alpha quantity squared plus beta squared, where S is greater than negative alpha. All right? Don't worry about the last two. Yung huling dalawa ay malamang may encounter nyo lang yan sa project. All right? So kasi hindi naman siya standard na kasama sa math 151. I just want you to know that they exist for the sake of probably the project. And lastly, meron tayong Laplace transform ng logarithmic. Ito ay wala rin sa slides, pero I think it would be helpful pag na-encounter nyo later. Laplace transform ng ln ng t. Ito ay equals sa negative ln ng s minus gamma over s, where gamma, which is approximately equal to 0.5772166, and so di pala approximately equal. Gawin ko ng equal. Tapos may dot, dot, dot na lang dito. It's an irrational number called the Euler-Mascheroni constant. Euler-Mascheroni constant. Okay. Actually, this guy is equal to the integral from 1 to positive infinity ng negative 1 over x plus 1 over floor ni x dx. All right. So that's the Euler-Mascheroni constant. And then I would like to introduce you to two other functions that are actually very handy in applications. Una ay yung, simulan ko sa Dirac delta function. Dirac delta function. Although this is called a function, hindi siya technically mathematical function. Ito ay na-invento ng mga, or na-discover ng mga engineers when they study applications. Specifically, this is the model for an impulse function. So imagine you have a system. Say meron kang isang vibrating, meron kang isang halimbawa string. Okay? When you pluck the string, say at the middle, so pinol mo lang to, so pinlock mo siyang ganun, oops, nadala siya. Kung hihigitin mo siya dun sa gitna, a very huge impulse, or you pinch it using a very large energy at a particular time, yun yung minomodel ng Dirac delta function. That's why the Dirac delta function is usually called the hammer blow impulse, because parang isa siyang hataw ng martilyo. Sandaling-sandali mo lang siya mararamdaman, pero super sakit niya. All right? Kasi nga, ang idea ng Dirac delta function, this is the function that is delta of x is equal to 0 whenever x is not equal to 0, and the integral from negative infinity to infinity of delta x dx is equal to 1. So siya yung function na palaging 0. Laging 0 yung value ni delta of x except dun sa origin, kung saan ka pupukpukin ng martilyo. All right? So dun magfo-focus yung energy. So 0 siya everywhere, pero at that particular value of x, when x is equal to 0, may napakalakas na energy na tumama sa kanya, so hard that the integral of delta x is was made equal to 1. Kasi kung i-graph nyo itong Dirac delta, bakit yung x equals 0? So ibig sabihin, 0 siya palagi, 0 siya dito, pero sa x equals 0, dapat mataas yung function value niya para yung integral from negative infinity to infinity ay maging equal kay 1. Right? But mathematically, this doesn't make sense kasi di ba ang integral or area under the region or under the graph of the region. So from everywhere except at the point x equals 0, flat yung graph niya. Nandun siya sa x-axis. So sa area niya supposedly ay 0, meron lang irregularity na naganap sa x equals 0 that required the integral to be equal to 1. So kaya yung ibang description sa Dirac delta, it is 0 whenever x is not equal to 0, but this is infinity when x is equal to 0. Kasi dapat super taas ng energy sa x equals 0 para magawa niyang equal kay 1 yung integral from negative infinity to infinity. Right? And there's no such function in the mathematical sense that can achieve this. Kaya hindi to isa talagang function. Pero ang tawag natin Dirac delta function. Pero actually, if you will go into advanced studies sa graduate school, malalaman nyo ito isang tinatawag na distribution. It's a generalized distribution. Okay? So, but that's the idea behind the Dirac delta function. And there's another interesting property of the Dirac delta function. If you integrate a certain function f of x against a translation of the Dirac delta function. So pag kinuha mo ang integral ng kahit anong function f of x times the Dirac delta function at x minus a from negative infinity to infinity, makukuha mong value ay f of a lamang. Right? So this is another interesting property of the Dirac delta function. Some authors use this as the precise definition of the Dirac delta function. Okay, what I want you to take away, aside from the physical relevance of the Dirac delta function, is the Laplace transform of the Dirac delta function. Okay, ang Laplace transform ng Dirac delta function ay 1, constant 1. Okay. And then, so that's it. And then another one, this is called the Heaviside function. The Heaviside function is simply a unit step function. So ito yung function na ganito yung itsura. It's a conditional function. Tawagin natin siyang h, the usual notation for the Heaviside function. H of t is equal to 0 when t is less than or equal to 0, and it is equal to 1 when t is greater than 0. So ito naman yung Heaviside function. 0 siya kapag hindi positive yung t, pag positive na si t, saka siya magiging equal kay 1. That's the Heaviside function. And the nice thing about the Heaviside function, ang derivative or ang Heaviside function o ang derivative ng Heaviside function ay Dirac delta function. So the derivative of the Heaviside function is equal to the Dirac delta function, and the Laplace transform of the Heaviside function is equal to ano ang value nito? Ang value nito ay medyo komplikado. It's actually it's 1 over s. Let's see. Yeah, it's 1 over s. Okay? So ito yung mga ito yung mga additional functions na baka kailanganin natin sa project, okay? Now, let's see. Before we leave, any questions about these functions? Or you want to take a screenshot of this handwritten notes that I included? So please do so now. Screenshot yun na yan. Okay. And then another screenshot here. Okay, so now let's move ahead and look at chapter 4.3, which is basically answering the question, kailan nag-exist yung Laplace transform? Sabi natin dati, yung Laplace transform ay nag-exist lamang kapag yung improper integral ay nag-exist. But let's see, ano yung mga theoretical conditions para hindi natin kailangang i-attempt muna na i-solve yung integral so that we know whether the Laplace transform exists or not. Okay? So una, kailangan ko munang i-define kung ano ang ibig sabihin ng isang piecewise continuous function. Alright? Ang tawag dito sa slides ay sectionally continuous function. But basically, I want to call it a piecewise continuous function. Pero parehas lang naman, tomato, tomato. But whenever I'm referring to it, I call it as a piecewise continuous function. It's a piecewise continuous function. Never mind these two parts. The function f is piecewise continuous over the closed interval AB if the subinterval can be divided into a finite number of subintervals such that f is continuous on CI, comma DI. Right? So dapat continuous yung capital F sa lahat ng subintervals doon sa yung malaking interval. If that happens, then we say that F is sectionally or is piecewise continuous over the closed interval AB. So just a quick recall, kailan nagiging continuous ang isang function sa isang closed interval? Kailangan siya ay continuous muna dun sa open interval, tapos nag-exist yung limit from the right at the left boundary point at yung limit from the left at the right boundary point. At sila ay equal dun sa function values. So, yeah. Medyo relax pala itong definition 4.3.1. It doesn't require that f of t is equal to t of c sabay. Let me see. Yeah, kasi mag-i-integrate ako sa endpoints. Kaya lang yung function value sa endpoints dapat mag-exist. Mag-exist yung limit, mag-exist yung improper integral. Okay, so yeah, now I'm convinced. Kanina hindi ako convinced eh. So, eto na lang. Sundin na lang natin yung nasa slide. Kasi mas restrictive yung binigay kong definition kanina na siya ay continuous dapat sa lahat ng closed interval. Kasi para maging continuous sa closed interval, dapat itong dalawang conditions na to ay nangyayari, plus dapat itong limit na to ay equal sa f of ci, tapos itong limit na to dapat equal sa f of di. Pero hindi kailangan na equal sa function values dun sa endpoints yung magkabilang limits, right? So sundin na lang natin to, mas generic. Kasi totoo pa rin naman yung sinabi ko kanina, pero pag tinanggal mo yung condition na itong limit na to ay equal sa f of ci, tapos yung limit na to ay equal sa f of di, all of the results that will follow will still be true. Alright? So ito yung mas malaking theorem. So ito yung mag-lead sa atin sa isang mas malaking theorem. So ito na lang yung sundin natin. So that's what we mean by sectionally continuous. And if you look at it graphically, dapat ay kaya mong hatiyan. Hindi na ngayon kailangan na continuous yung buong function sa buong closed interval. Ang sinasabi ng pagiging piecewise continuous, you can subdivide the mother interval into several subintervals such that your function is continuous on each of the subintervals. So if this is my function f, I can say that this function is not continuous on the closed interval 0, 6 because I cannot sketch the graph of the function without lifting my pen all throughout the interval 0 to 6. But I can draw pieces of the graph without lifting my pen. I trace this without lifting my pen. I trace this without lifting my pen. Same thing goes here. Same thing goes here. And that is fine. So that means this function is piecewise continuous. All right? All good? So yun yung piecewise continuity. Now, another thing that I want to consider is kailan naman mas pwede nating sabihin ng isang function ay exponential ang order. So a function f is said to be of exponential order as t approaches infinity if there exists constants m and b and a fixed t value c such that the absolute value of f of t is less than or equal to m times e to the bt for t greater than or equal to c. Yung mga nag-152 dyan or nag-174 this semester, you should be familiar with this because all this is telling us is that f of t is a big O of e to the bt. Right? Ibig sabihin nito, f is asymptotically bounded above. So asymptotically bounded above by a multiple of e to the bt. Right? Kasi in the long run, kapag ka masyado nang mataas si t, after some c value, so when t is sufficiently large enough, yung magnitude ni f ay mas maliit na sa isang multiple ng e to the bt. So there is a multiple of e to the bt that serves as an asymptotic upper bound of the absolute value of f of t as t goes to infinity. And basically, that's the idea behind big O notation. So si f of t ay exponential order kapag ka si f ay big O ni e to the bt. Or there is a scalar multiple of e to the bt such that in the long run, that multiple will be an upper bound for f of t. Bakit ko kailangan itong dalawang definitions na to? Kasi pag itong dalawang properties na to ay na-achieve ng isang function, sure tayo na siya ay magkakaroon ng Laplace transform. So you just need to check these two conditions. Alam niyo na mag-exist yung Laplace transform. So you can move ahead and now compute for the actual Laplace transform. Right? Now, that is where I am leading to. Bakit nag-exist yung Laplace transform kapag ang isang function ay sectionally continuous plus exponential order? Pero dito, inassume muna niya na siya ay exponential yung order. Kasi kung siya ay hindi piecewise continuous, pwede kong hati-hatiin yung intervals into several sub-intervals kung saan bawat isang improper integral ay mag-exist. But that's a technical detail that you can include later in the proof. But let's see. So ito, gusto ko sanang i-try kung nag-exist yung Laplace transform ni capital T. So all I need to do is to apply the definition of the Laplace transform, all right, para sa improper integral na ito. Now, we know that in the long run, actually, wag muna yan. Hatiin ko muna. Yeah, tama yung sinabi ko kanya. In the long run, we know that, we know the behavior of f of t. It's of exponential order. So in the long run, this inequality is true. So ang gagawin ko ngayon, hahatiin ko yung interval 0 to infinity into the intervals 0 to c, tapos c to positive infinity. Okay? So hatiin ko siya sa dalawang intervals na yan kasi si c yung magiging hatian. Kasi nagiging upper bound na ni capital F si m e to the bt kapag ka lumampas na ako ng c. Right? Kaya ako siya hinate into these two parts. Now, this guy is or can easily be solved, especially if f is well behaved kasi nasa finite interval ka lang naman. So this should be a finite number. Okay? So titingnan na lang natin ito. Kasi ito yung may improper upper bound kasi yung upper bound ay infinite. But remember that from c to positive infinity, capital F is bounded above by the multiple of m e to the bt. So here we get e to the negative st f of t dt is less than or equal to the integral of e to the negative st times the absolute value of f of t. Kasi nga si f posible maging negative sometimes. So pag nilagyan mo siya ng absolute value, mas lumalaki yung value ni capital F. Remember? Little f is less than capital F is less than or equal to the absolute value of capital F. Kaya naman, pag pinalitan ko to ng absolute value ni f, nasa loob ng integral, makukuha ko ay less than or equal to pa rin. Pero, we know that on the interval 0 to positive infinity, this guy is bounded above by this guy. So if I will replace the absolute value of f by m e to the bt, the resulting integral will be greater than or equal to the previous one. Okay? Tapos si m pwede kong ilabas ng integration kasi si m ay constant na nanggaling dun sa pagiging big O of e to the bt niya. So matitira na lamang sa loob ay integral ng bt minus st dt. At doon tayo ngayon magpo-focus. Alright? So integrate mo yan. Tapos integrate, usual improper integration, and you will end up with this limit, right? This limit will exist when s is greater than b, because when s is greater than b, magne-negative itong mga nasa numerators. Okay? So that means this function is absolutely convergent. Nag-exist yung improper integral niya or improper integral nung absolute value, which is an upper bound for this integral. So ibig sabihin nag-exist to. So therefore, this must also exist. This is finite. So that means this is also finite. This guy is finite plus something that is finite on a finite interval. So the sum will be finite. So this improper integral will exist. But what is this again? This is the Laplace transform of your function capital F. So in the end, we can conclude that if we have a function that is of exponential order, then this Laplace transform will exist. Okay? And a bigger theorem than that is theorem 4.3.2, which tells us that if we have the combo of f being piecewise continuous and being of exponential order, yun yung tinatawag natin na class A function. So yung mga class A functions, sila yung piecewise continuous at sila yung of exponential order. Then laging mag-exist yung Laplace transform whenever S is greater than B. Alright? So yun yung sufficient condition para masabi natin na ang isang function ay may Laplace transform. Pag alam mo siya ay class A, lagi siyang may Laplace transform. Kailan siya magiging class A? Dapat siya ay exponential order. So dapat siya ay big O ng e to the bt for some b. And it should be piecewise continuous to allow the breaking down of the major interval into several subintervals kung saan mag-exist yung finite integrals. Okay? So yun lang yung kailangan yung tandaan. Pag class A, may Laplace transform. And I guess that ends chapter 4.3. Maiksi lang yung mga chapters dito pero they are pretty loaded. So I don't want to ram through them. So any questions? Halata na nagmamadali ako, no? No questions? All right. So if there are none, so na-establish na natin yung existence ng mga Laplace transforms. Let's see, what are some of the interesting properties of the Laplace transform in relation to the course ordinary differential equations? The first one, meron pala ako ditong pa-handout. Ito yung listahan ng mga Laplace transforms na pwede nyo magamit. So skip ko na lang yan. Pwede nyo i-download kay Canvas. Uy, tapos na pala yung set of slides here. So let me shift to my next. There we go. Okay, now let's go to section 4.4 and 4.5, which talks about the basic properties of the Laplace transform. Now, una, tingnan natin ano yung derivative ng Laplace transform. Right? Kasi later makita natin, we want to do several operations on the Laplace transform. Unahin natin ano yung derivative ng isang Laplace transform. So in theorem 4.4.1, we were told that we need to assume that f is class A. Kasi sure na tayo kung siya ay class A, ibig sabihin yung Laplace transform for sure ay mag-exist. So we can do a lot of things with the Laplace transform kasi sure na tayo na sila ay nag-exist. So remember, this is our formula for the Laplace transform. Now, what will happen if I want to take the derivative of both sides? Okay, kunin ko yung derivative nito. Kunin ko yung derivative nito. So I'll have f prime of s. But what is the effect of the differentiation with respect to s of the Laplace transform to the function inside or its relation with respect to the Laplace transform. So pagka pag nagde-differentiate ka ng Laplace transform, ano kaya yung nangyayari sa loob ng Laplace transform? Well, coming from this equation, so i-differentiate ko lang both sides. So I was supposed to get dds of f of s, or derivative with respect to s ni f of s, ay equals sa derivative with respect to s ng integral from 0 to infinity ng e to the negative st f of t dt. Okay? Tapos, dahil class A yung function, just a warning, you cannot always do this, but you can do this definitely for functions of class A. Pag class A yung isang function capital F at involved siya sa integration against e to the negative st with a combo derivative at the beginning, the derivative can enter the integral. As long as the derivative is with respect, the integral is with respect to a different variable. Yung integral ay kinocompute natin with respect to t, yung derivative kinocompute natin with respect to s. Pag class A yung function, yung derivative with respect to s can enter the integral. But this doesn't happen in general. May mga conditions kung kailan natin pwedeng pagpalitin yung order ng integration at differentiation. But I won't go into the details. That's for another course, pang advanced calculus or advanced analysis. Ano? Pero if f is class A, then the integral, or the derivative of the integral, e to the negative st, capital F of t, dt, ay equals sa integral from 0 to infinity ng dds ng e to the negative st times f of t dt. So nabago yung order of the integration and the differentiation. We can differentiate first bago natin siya i-integrate. Bakit ko gustong unahin yung derivative dito? Kasi derivative lang siya with respect to s. Isa lang naman na factor dun sa integrand yung nagdidepende kay s, yung exponential na e to the negative st. So the function f solely of the variable t can come out of the differentiation procedure. So matitira na lang derivative with respect to s ng e to the negative st. Pero ano ang derivative na yon? E to the negative st times negative t, capital F of t dt. Right? Nag-chain rule lang ako doon sa derivative with respect to s. And then compare this thing that we have right now to the definition ng Laplace transform. Diba, ang Laplace transform ay integral ng e to the negative st times the function that gusto nating ma-Laplace transform. So in this particular case, para lang pala tong Laplace transform ng negative t f of t. Pero what did we see computed? We computed the derivative with respect to s of the Laplace transform of f. So essentially, this guy pala is the derivative of the Laplace transform. Okay? And that's what you have over here. Pag nag-differentiate pala tayo ng Laplace transform, it's the same as taking the Laplace transform of negative t times the original function. Okay? And you can use this in reverse. Kapag nagpapalaplace transform ako sa inyo ng negative t times a function capital F from the list, hindi nyo na kailangan mag-improper integral. Kasi pwedeng negative t, tapos kung alam nyo ang Laplace transform ni f, i-differentiate nyo na lang yung Laplace transform ni little f. Okay? I'll illustrate that process later, pero let me just generalize this theorem first. You can do this thing repetitively, all right? So yan yung first derivative. So pag kinuha mo yung second derivative ng Laplace transform, so little f prime of s, so magkakaroon ka lang dito ng isa pang derivative. Tapos pwede mo yung ipasok ulit sa integral kasi class A naman si capital F. So magiging second derivative ito ng e to the negative st. So ibig sabihin, magkakaroon pa tayo ng isang negative t na factor dito. So we'll have another negative t. So we'll have negative t squared. And then that will also happen if you're on the third derivative, the fourth derivative, and so on. So eventually, we'll have the following theorem. Oops, sobra. Kung si little f ang Laplace transform ni big F, then the nth derivative, there's a typo here, please put parentheses there. The nth derivative of little f is equal to the Laplace transform of negative t to the n. Hold on. I think the exponent should be here. Double check ko nga yan. Let me Google this a little quickly. Derivative. Because I think dapat yung negative. Yeah, I think that is right. Hindi ko siya makita sa Google kasi mas lumalabas sa Google results ay derivative, Laplace transform ng derivative. Kakaunti yung nagdi-discuss ng derivative ng Laplace transform. Pero it makes sense that it will be negative t to the power n times f of t. Kasi pag kinuha ko yung second derivative, so f double prime of s ay equals sa derivative ng integral ng 0 to positive infinity ng e to the negative st times negative t capital F of t dt, right? So yan yung second derivative kasi i-differentiate ko lang yung first derivative. And then again, this guy will still be big O of e to the bt, so exponential, class A pa rin yan. So pwedeng pumasok yung integral sa loob yung derivative sa loob ng integral. So kailangan kong i-differentiate ito with respect to s. So ito ay mga constants with respect to s. So magkakaroon lang ako ng derivative ni e to the negative st, which is e to the negative st times negative t. But I have a negative t here. So magkaka-square lang yan. Tapos f of t dt. And this will happen repetitively or as I increase the order of the derivative. So yeah, kindly correct your notes. It should be una, nakaparenthesis si n. It's the nth derivative of f with respect to s. Tapos ito ay equal sa Laplace transform ng negative t to the power n times f of t. Ang naka-raise kay n ay si negative t, hindi lang si t. Good? Do you agree with that statement? Tama naman, no? Okay. Thank you, Kiefer. Oh, thank you, Chriselle, Jen Raphael, Zaira, Billy. Okay. Let's see. So let's see how this is used or how this will be useful. Because you might be telling, sabi mo, sir, kanina, ang promise mo, pag nagla-Laplace transform na, wala na dapat involved na derivative. Ano? Pero magagamit kasi ito sa inversion at sa pagko-compute ng ilan na ring Laplace transforms. So, halimbawa, pinahanap ko sa inyo ang Laplace transform ng t sine kt. So wala tayong formula rito. Meron tayong formula para sa Laplace transform ng sine kt, right? That's k over s squared plus k squared. Pero anong mangyayari pag may multiplier siya ni t? So if you will try to use the definition, kasi wala nga tayong theorem para dito, may kita mo na magkakaroon ka ng integral ng e to the negative st times t times sine kt. So magkakaroon ka ng mas komplikado na integrand. So baka kailangan mag-integration by parts in 2 levels. Tama ba? Yeah, I think you need 2 levels kasi mag-integration by parts ka within an integration by parts. Unless t there. Yeah. So masyadong komplikado yung magiging computation ng improper integral. But you can notice that this guy is a multiple, it's just as if we are multiplying sine kt by a power of negative t, right? Or kung kulang ka lang ng isang negative sign, madali lang namang mag-introduce ng negative sign kasi ang Laplace transform naman ay linear. So ibig sabihin, I can write this as the negative of the Laplace transform of negative t times sine kt. Agree? Kasi linear operator lang naman si Laplace transform. Now, it is now in a more familiar form because I have a power of negative t times a function who I know the Laplace transform of, right? So ito ay negative t to the power something. In particular, it is negative t to the power 1 times sine kt. Oh, sabi nung kabilang theorem, kapag ka nag-differentiate ka ng isang Laplace transform, ang epekto niya dun sa loob ng Laplace, sa loob ng Laplace operator, yung original function capital N na multiply lang ng negative t quantity to the power n, right? So ibig sabihin, kailangan ko lang palang kunin ang Laplace transform ni sine kt dahil may isa akong multiplier na negative t, i-differentiate ko yung Laplace transform na yon one time. And sure enough, the solution was presented this way. Kinuha niya muna yung Laplace transform ng sine kt from our table, and then they did the observation that they did the process behind the observation that we had. Kinuha niyo yung derivative ng Laplace transform. And remember, yung pag-differentiate ng Laplace transform just translates to multiplying negative t yung original function. Okay? So dito, nag-quotient rule lang siya. Remember, nag-differentiate ka rito with respect to s. Okay? Tapos, sinimplify niya, and then you have this. Pero ang original problem kung pinapasolve ay Laplace transform ng t sine kt. Meron tong negative na sobra. So you can factor out the negative sign para lumabas si negative 1. Mawawala na siya. So magkakaroon ka na lang ng t sine kt. And then to remove the negative 1 in front of the Laplace transform, you just divide both sides by negative 1. So this negative sign will vanish and we'll have the Laplace transform of t sine kt. Okay? I don't think you need to put this in your list, pero it's good to know that the Laplace transform of t sine kt is just the negative of the derivative of the Laplace transform of sine kt. Okay? Tingin pa tayo ng isang example. Similar lang pala to, no? Sine t, Laplace transform ng t cosine kt. Same process, ano? Nagkaiba lamang yung umpisa natin. At mas komplikado ngayon yung product rule kasi meron ka na ring s sa numerator. Kanina, k lang yung numerator natin, which is a constant. This time, we are differentiating ng may s dun sa numerator. At ang siste, nagdi-differentiate tayo with respect to s. Okay? Good? Yan. Ito yung medyo masaya. Laplace transform ng t cubed e to the kt. So just observe first, I have a negative, I have a power of t here. Kung kukulangin man ako ng negative sign mamaya, madali na siyang isupply. Tapos e to the kt, we know the Laplace transform of e to the kt. It is just 1 over s minus k, right? And that's where you can start your solution. I don't fancy how the solution was written, but you can write it later in another form that you want. Okay? So, pero doon siya nag-start kasi alam niya yung Laplace transform ng e to the kt and you're just multiplying by a power of t. Okay? So, dahil ito ay t cubed, meron siyang third power ni t, so malamang kailangan ko mag-differentiate 3 times. So, pag kinuha mo yung third derivative ng Laplace transform ni e to the kt, ang makukuha mong left-hand side ay yung Laplace transform ng quantity negative t raised to the third power. So tama yung correction natin kanina. Negative t to the power 3. So yun yung epekto, yun yung cost ng pagde-differentiate. Pag differentiate mo si Laplace transform, kailangan mo mag-multiply ng negative t to that order of the derivative doon sa loob ng Laplace transform. And then compute this third derivative. You're going to get 6 times s minus k to the minus 4. Rewrite it in a friendlier manner. And then divide both sides by -1. Because what you'll get here, this guy is Laplace transform ng negative t cube e to the kt. Pero ang gusto natin ay Laplace transform ng t cube e to the kt. So ilalabas ko lang to. Tapos divide both sides by negative. That's where this negative sign came from. So we can conclude that the Laplace transform of t cube e to the kt is -6 over s minus k to the 4th power. Cool? Any questions? Pwede na ba ulit magpa-quiz about this? Or magpa-homework? At syempre, hindi na kayo sumagot nung usapang homework na, no? Oh, thank you, Keeper. Oh, delayed lang pala. All right. Sige. But I hope the process is clear. There's nothing much to it. Basta alam mo yung Laplace transform. Tapos, i-multiply mo lang siya ng power ni t. Then you'll get your, then that will result to something involving the derivative of the Laplace transform. Okay? So I'll give you 30 seconds to digest this kasi nag-alarm yung washing machine. So naglalabada kasi ako habang nag-discuss tayo. Hold on. I-off ko lang yung alarm. All right, so now I'm back. Nasa na tayo? Okay. Oh, yeah, mas actually hindi naman to komplikado. Let's just sketch the solution, and then try to I'll show you the approach, or I'll tell you my approach, and then try to recreate the solution later, So this is telling us to show that this is an identity, that s over s squared plus k squared quantity squared is equal to the Laplace transform of sine kt times t over 2k, right? So what you can do here is to start with the Laplace transform. So you can do Laplace transform ng sine kt. Right. Kasi pwede mo itong tan, ito si f, ito ay multiplier na negative t to the quantity, negative t to the n all over 2k, but 2k is just a constant, right? So what we can do now is to say that this guy, or actually, pwedeng ganito yung approach. Mas ganito ko siya sinusolve. Doon ako nag-start sa left-hand side. So we'll have t over 2k times sine kt. Okay. Also practice na yung grouping symbol para dun sa Laplace transform ay curly braces. Kasi pagka naglagay ka pa dyan ng parentheses, para hindi dumami yung mga parentheses dun sa loob ng Laplace transform. So para hindi siya ma-confuse with the grouping symbol for the entire Laplace transform, curly braces yung ginagamit natin para dun sa grouping symbol ng Laplace transform. Okay? Now I know that this is equal to 1 over 2k. I can take 1 over 2k out of the Laplace transform because it's a constant with respect to t. Si k ay constant lang naman yan. So wala siyang t, so pwede ko siyang ilabas. Then ito ay maging Laplace transform na lamang ng t times sine kt. Pero I know kung ano yung nangyayari sa Laplace transform kapag nagmo-multiply ako ng power ni negative t. But here I only have a negative t, so let's introduce a negative sign here para magkaroon ng negative sign doon sa loob ng Laplace transform. Kasi sabi ko lang na braces, ako yung hindi sumusunod. Sorry. Oops, what happened? Right? Tapos alam ko na, ito ay magiging negative 1 over 2k times the derivative of the Laplace transform of sine kt. Kasi nga, pag nag-differentiate ka ng Laplace transform, nagkakaroon ka lamang ng negative t na multiplier. But we know what the Laplace transform of sine kt is. So this is just 1 over 2k times the derivative of k over s squared plus k squared, provided that s is greater than 0. Okay? Tapos ito na ngayon, i-differentiate mo lang yan, i-multiply mo ng nawala yung negative, sorry. Nawala yung negative. So remember, negative 1 yan. And then get the derivative, multiply it by minus 1 over 2k, then you will get the right-hand side. You will get this guy. Okay? And I'll leave that solution to you. Okay? Ito na lang naman, di-differentiate nyo na lang yan. And I hope the process is clear. Ano? I usually do this rather than the way the solution is written. But at least now you have two different approaches. You can pick one which suits you better. Okay? Okay na ba yun? Hindi ko na tutuloy kasi partial quotient rule lang naman yon. So kailangan yung tandaan. But I hope the idea is clear. You need to reduce your Laplace transform to the Laplace transform of a power of negative t. Do the adjustment on the sign. You can just simply introduce two negative 1 as factors para ma-cancel out yung excess or yung kulang na negative sign na gusto mo dun sa Laplace transform, and then you will be good. Okay? All right, so let's see. What's next? Same thing goes here, right? Kagandahan lang dito, meron ka ng negative t sa unahan. Right? Skip na yan. Then another one. Let's see. Maybe we can talk about the last one. Yeah. Paano ko to i-show? I'll start with this guy, and I'll use the linearity property of the Laplace transform. So maybe let's start on a new page. Wait. Come on. Naghang yung notability ko. Okay, hold on, guys. Let me just... Let me try if I can fix it. Okay, there you go. Naghang lang siya. Let me start sharing again. Okay. Right. So, bigla naman nag-restart si Notability. And it opened the previous file. Why? Okay. I am... Andito tayo, no? This is what we want to do. Let me add a page. Okay, I think this is good. Right. Ito yung gusto nating i-solve. So I will. There's a solution in the slides, but this is how I usually approach it. Ano, you can decide which one is better for you. So I'll start with the right-hand side because there's much we can do to the right-hand side than the left. So I'll start with the Laplace transform ng 1 over 2k cubed times sine kt minus kt cosine kt. Okay. Now, I will use the linearity property of the Laplace transform first by taking 1 over 2k cube out of the Laplace transform because the function we have inside the Laplace transform is a function of t. It is not a function of k. K is a constant, so we can take it out. So I'll have 1 over 2k cube times the Laplace transform ng sine kt minus kt cosine ng kt. Okay. And again, I'll use linearity of the Laplace transform in the sense that the Laplace transform of a sum is the sum of the Laplace transforms. So I'll have 1 over 2k cubed times Laplace transform ng sine kt, okay, plus Laplace transform, Laplace transform ng kt, ng negative kt cosine kt. Oh, but I have a k here, which is a constant. Linearity property uli ng Laplace transform, pwede ko yung ilabas. Literally ko siyang nilabas, all right, of the Laplace transform. And then next step, oh, I know the Laplace transform of e to the kt, of sine kt. It is what? It is k over s squared plus k squared, provided that s is greater than 0, okay, plus k times, oh, here I have a negative t, a first power of negative t times cosine t. So that tells me, derivative lang ito ng Laplace transform ni cosine kt. You can get rid of any power of negative t by just differentiating sufficiently number of times. Okay. And then, I can compute the Laplace transform of cosine kt. Nandun yan sa table natin. So we'll have this. Plus k times derivative with respect to s ng Laplace transform ng cosine kt ay what? S over s squared plus k squared. Same condition dito, s is greater than 0, intersection with the condition kanina. So nandun pa rin tayo sa condition na s greater than 0. Okay? And then wala nang Laplace transformation dito, so I think it's an elementary exercise for you to take the derivative of this guy and then simplify the resulting expression. Hopefully, you will get, hindi pala hopefully, you will get for sure 1 over s squared plus k squared quantity squared. Of course, there are there could be a couple of more algebra steps here, but eventually you'll get there. Good. I'll take your silence as a yes. So let's see. Oh, practice problem. I think it's time for a homework. So which one do you want to answer? Tanggalin ko lang si A. Daya kasi ni A. A pa naman yung una yung nasipat, ano? Homework ano na tayo? Homework 13, 14, what? What homework are we on? Homework 12 na pala. Homework 12. Meron na ba tayong homework 12? Meron na tayong homework 12. Pero homework 11 yung nasulat ko kay Canvas. So sorry. So this should be homework 13. Sorry for the confusion. Yeah, dalawa yung homework 11. So thank you, Kiefer and Zaira. So yeah, papalitan ko yung pangalan. Homework 12 yung isa. Then this would be homework 13. When do you want this due? Ito na rin yung review nyo para sa exam, para sa part na to, ano? Is it okay if we do this, ano sabi natin na usual deadline natin? 11:59 p.m. ng Tuesday o Wednesday? O paiba-iba pa rin tayo? Oh, let's do it December 14. Wednesday na lang sabi ni Victor. Sure, sure. So December 14. So yan yung, pili lang kayo ng isa. Choose one. Choose one of the following. Okay? Isa lang, para hindi ako mahirapan mag-check. Ano? So deadline December 14. Okay? I'll post the announcement later in Canvas. And I think with that, we're ready to do chapter 4.5. Can I do it in 9 minutes? I can try. So, kanina tiningnan natin yung derivative ng Laplace transform. Kinumpute mo muna yung Laplace transform, kinuha natin yung derivative ng Laplace transform, and we discovered or we observed that that is just the Laplace transform of negative t times the function capital F. Okay? Now, yung baliktad naman yung tingnan natin. Ano ngayon ang Laplace transform ng derivative? Okay? And we'll just present it without proof, theorem 4.5.1. So ito yung mga conditions. So si F dapat ay continuous. Kasi pagka si F ay hindi continuous, automatically na siya ay discontinuous. Sorry. Kapag ka si F ay hindi continuous, siya ay automatically hindi differentiable. Tama ba? Differentiability implies continuity. Siya ay contrapositive ng discontinuity implies non-differentiability. Good. So pag si capital F kasi ay discontinuous, automatically si capital F ay hindi differentiable. Okay? So there's no point in talking about the derivative, the Laplace transform of F prime because F prime will not exist. But in the chance or in the event that F is continuous, then it is possible to have a derivative. Okay? So it makes sense to talk about F prime or posible kang magkaroon ng F prime. And if F prime exists, and it so happened that F prime is also of class A, ibig sabihin siya ay piecewise continuous, si F prime, at si F prime ay big O ni e to the bt. So, ibig sabihin, kung yun ay nasa-satisfy, then, ang Laplace transform ng F prime ay equal sa, can you still see my annotations? Parang hindi na. Wala kayo nakikita ng annotations. Wala akong nakikita sa monitor ko. Let me restart my sharing. So makikita mo rito, siya lamang ay ang Laplace transform ng derivative ay parang nagiging multiplication naman ng power ni S tapos nag-add ka lang ng mga function values scaled by powers of S. So in particular, here's your formula. So kung first derivative lang yan, madali. Laplace transform ng first derivative of F, assuming that capital F is of class 1, siya lamang ay S, the variable in the Laplace transform, times the Laplace transform of capital F, right? So parang yung first derivative naging multiplication lang by S, pero ma-minusan mo siya ng F of 0. Okay? Tapos what if I want to get the Laplace transform of the second derivative of capital F? So kung kukunin natin yung Laplace transform ng second derivative ni F, siya lamang ay Laplace, but this is what? This is the Laplace transform ng derivative ni F prime. Okay? So pwede ko ngayong i-apply yung formula kanina, itong formula na to, pero i-apply ko siya kay F prime. Okay? Kasi ito ay Laplace transform ng derivative ni F. Pero ang Laplace transform ng F double prime ay Laplace transform ng derivative ni F prime. So pwede kong gamitin kay F prime itong formula na to. So I will have S times the Laplace transform of F prime minus F prime evaluated at 0. Right? Kasi nga ito ay f kanina pero si f papalitan ko ng f prime, magkakaroon ako nito. Okay? Tapos, Laplace transform ng f prime yung nandito, pwede kong gamitin itong formula na to exactly. Right? So the Laplace transform of f prime will be replaced by s times the Laplace transform of f minus f of 0. Then I'll copy over the artifacts from the last line. Okay? Tapos simplify ko lang, magkakaroon ako ng s squared Laplace transform ni f minus s times f of 0 minus f prime of 0. And then further simplify it, alam natin yung Laplace transform ni capital F, siya ay si little f. So you'll have s squared f of s minus s f of 0 minus f prime of 0. And now you will see, nawawala talaga yung differentiation. Yung differentiation, mukhang napapalitan lang by a multiplication of a power of s minus some terms over here. Okay? Tapos ano yung pattern dito? So kung meron ka ng, kung ano yung order ng derivative, second order yung derivative, yung Laplace transform, mamumultiply ng s squared. Tapos, magkakaroon ka ng mga subtrahends na decreasing power of s. So magkakaroon ka ng s to the 1, tapos magkakaroon ka ng s to the 0. Right? Tapos ano yung multiplier sa kanila? Ang multiplier sa kanila ay function values kay 0 in increasing derivatives. Okay? So with that pattern, can you guess what would be the Laplace transform of the third derivative? Ganito ko siya tinatandaan kasi super dami ng formulas. So ito ay, third order derivative. So magkakaroon ako ng s cube times Laplace transform ni capital F minus decreasing power dapat ni S. So nagsimula ako sa s cube. So ang susunod na ay minus s squared times f of 0. Tapos minus s times f prime of 0. So lumiliit yung exponent ni s hanggang makarating ka kay s to the 0. Tapos palaki yung derivative ni capital F. Alright. So now I will have as last term minus f double prime of 0. Alright. Do you guys see the pattern there? So s to the n muna times Laplace transform minus pababa na ng pababa na power ni s pero multiply ng pataas na number ni f. Parang spaghetti lang. Anyway. Hindi ko alam kung naabutan nyo pa yung panahon ng mga spaghetti pataas at pababa. Generation gap na ba yun? Feeling ko hindi pa naman ano. Alright? Okay, and you have that over here. So, ito yung mahabang formula dyan. And in general, here's the formula. You can prove this via PMI. Ito yung sinasabi ko kanina na pattern. Okay. So you can either memorize this one or share the mnemonic that I just use the mnemonic that I just shared with you kanina. Okay. Now, why is this helpful in solving partial differential or ordinary differential equations? Add lang ako ng isa. Don't worry, last few remarks na. So time na rin naman. Okay. Okay, 4.6. Okay. So halimbawa, given tayo ng second order differential equation. So halimbawa, x double prime of t plus x of t equals cosine of t. Halimbawa, ito yung given ODE. Second order siya. So to get a unique solution, we need to have two conditions, right? Dalawang conditions na masasatisfy ng function x and possibly its derivative. So say I give the following initial conditions, that x of 0 is equal to 0 and x prime of 0 is equal to 1. Okay. And bakit ito yung ODE na gusto kong isolve? It's an initial condition problem, right? Because we have the ODE and then we have two initial conditions. So makakuha tayo ng isang unique particular solution. Okay? Now, you can try the methods that we discussed before to solve this ODE. Pero let's try to see how the Laplace transform will figure in this system, right? So ang gagawin ko lang, kukunin ko yung Laplace transform ng parehas na side ng equations. Kasi well-defined ang Laplace transform. So kung equal ang dalawang functions, equal dapat yung kanilang Laplace transform. And sabi sa equation, ito ay equal dito. Dahil equal silang dalawa sa isa't isa, so yung Laplace transforms nila dapat equal din. So that means Laplace transform ng x double prime of t plus x of t ay equal dapat sa Laplace transform ni cosine t. Tapos medyo masaya ka na dun sa right-hand side kasi alam mo yung Laplace transform ng cosine t. Ito lamang ay s over s squared plus k squared. S must be greater than 0. Okay? Tapos gagamitin mo yung linearity ng Laplace transform sa left. We'll have Laplace transform ng x double prime plus Laplace transform ng x of t. Talagang pinilit kong isalba yung parenthesis at gawing braces. Okay. Now, and then, Laplace transform ko lang sila separately. Pero, Laplace transform ng derivative. So, yung differentiation sa Laplace domain, parang multiplication lang by a power of s. This is the second derivative. So, in the Laplace domain, that will just mean multiplication by s squared. So, I will have s squared times Laplace transform ng x. Tawagin kong x tilde, yung Laplace transform ni x. Tapos function na siya ni s, right? So I'll have x tilde of s. Tapos, dahil second order yan, kailangan ng decreasing power of s, pero increasing, ito ay x of 0, right? Tapos magkakaroon ng minus s to the 0, which is 1, times x prime of 0. Kasi nga, pababa ng pababa yung powers ni s, pataas ng pataas yung order ng derivatives. Okay? Tapos, Laplace transform, ito, Laplace transform ng x ay x tilde of s equals sa s squared over s squared plus k squared. S is greater than 0. Okay? And then you see here, oh, wala nang derivative involved. And then we can further take advantage of the initial conditions from the problem. S of 0 is equal to 0. X of 0 is equal to 0. Oy, merong x0 dito. So ito ay 0. Entire second term will vanish. X prime of 0, sabi sa problem ay equal kay 1. X prime of 0, so ito ay equal lamang kay 1. So we'll have s squared plus s squared times x tilde s plus x tilde s minus 1 equals s squared over s squared plus k squared. I can add 1 to both sides. Lipat ko na lang yon. Magiging plus. And then here, I can factor out x tilde kasi yung dalawang terms merong x tilde. So basically, magkakaroon lang tayo ng x tilde of s times s squared plus 1 ay equals sa s squared over s squared plus k squared plus 1, right? And then to get x tilde, I simply need to multiply or to divide both sides by s squared plus 1. So I'll have x tilde s equals s squared over s squared plus k squared times s squared plus 1 over s squared plus 1. Okay? Tapos ang problema ngayon ay, ito yung solution, x tilde. We have solved the algebraic equation. Pero kailangan kong bumalik sa time domain. Kailangan kong bumalik sa variable t. Now, how can I do that? I need to take the inverse Laplace transform. Kailangan kong isipin sino yung ni-Laplace transform para makuha ito. At yun yung kailangan ko para mahanap si x of t. At yun ang i-discuss natin next time. when we go to the next chapter. Ba't ang layo? That would be chapter 4.6. There we go. Inverse Laplace transforms. Okay? I'll end up here. 5 minutes overtime na ako, but do you guys have any questions? Questions? So if there are none, so thank you guys for coming today. So we'll see each other again on Friday para makompleto kung ano yung coverage ng pre-final exam. And then hopefully, matuloy na yung meet cute natin on Monday, right? So again, 10 to 12 noon, December 12 sa Math Building 101. All right? Yung mga magpapa-schedule ng special exam, kindly contact me as soon as possible. All right? Bye, guys.